Okay. We're going to do a practice problem. Escape velocity from the surface of the Earth. All right. We're going to have a few givens here. So here is the problem. Calculate the escape speed from the Earth for a spacecraft with a mass of 5,000 kilograms. So I'm going to pull out the given. It is going to be starting from the surface of the Earth and launched away. We are going to need some other numbers. So the mass of the Earth will be 5.97 times 10 to the 24 kilograms. And you can actually see that on the bottom of this particular sheet. Let's see. The mass of the Sun is also down there. And of course, we are going to need the radius of the Earth, which will be 6.37 times 10 to the 6 meters. All right, so with our givens, we start out at the surface of the Earth with some mass. We're launched out. We go an infinite distance away and escape. And at that point, our velocity would be equal to 0. That means we can say minus g mass of Earth, mass of spacecraft over r plus 1/2 mass of spacecraft, v of spacecraft to escape is equal to 0 plus 0. And the small mass appears in both. We'll rearrange this. So v escape is the square root of 2g mass of Earth over radius of Earth. All right, so let's see. Square root 6.674 times 10 to the minus 11. Accidentally hit recall there. Times, I forgot the 2, so g times 2 times mass of Earth 5.97 times 10 to the 24. Divide by 6.37 times 10 to the 6. Take the square root. We get 11,184 meters. Oops, not meters squared, meters per second. So it's right around 11 kilometers per second to escape from the Earth. All right, since we're here playing around with this and we've just got the equation again, let's think about what if you wanted to escape from the solar system. So here you'd have the Sun would be out here at 1 AU away, and we'd have to figure out how fast, starting at the orbit of the Earth, do we have to go to escape. So there we'll use the mass of the Sun and the distance between the Sun and the Earth. All right, I'm going to have to take a moment here. I remember it's something like 1.497 times 10 to the 11, but I'm never completely sure. So 1 AU in meters, 1.496. 1.496, I was surprisingly close, times, oops, 10 to the 11th meters. All right. So to escape from the solar system, we'll be taking 2 times 6.674 times 10 to the minus 11 newtons meters squared per kilo squared. Then we're going to have the mass of the Sun, which also is on the sheet, but it's 1.989 times 10 to the 30 kilograms. And then we'll divide by this distance, 1 AU, the mean Earth-Sun distance. 1.496 times 10 to the 11 meters, and we should get the escape speed from the solar system, which I believe is around 30 kilometers per second. So let's find out. 2.674, 10 to the minus 11, 1.989, 10 to the 30th, divide by 1.496, 10 to the 11th. I missed a 1 in my 10 to the 11th. All right, running back through the calculator, I'm just going back to the previous equation and adding my 1. Ah, that's actually a bit faster than I thought. All right, so that says 42,000 meters per second. So it's more like 42 kilometers per second. I'm checking that one because it does feel a little bit large. Solar system velocity. Okay, I'm going to have to pause for a moment. Okay, turned out what I found was correct, and 42,000 is right. It's just when I did the quick lookup on the internet, it was saying 16 kilometers per second, and I'm going, say what? It really is around 42,000 meters per second, 42 kilometers per second. So, booking it pretty good. Oh, right. That thing we sent to Pluto, it also is going at escape velocity, with extreme prejudice, I think. We've also had a couple of objects visit the solar system with escape velocity, so they aren't staying around. Oumuamua is probably the one you're most familiar with, but there was sort of a vaguely comet-like rock that we decided was also on a hyperbolic trajectory. All right. So there are some escape velocities, one from the Earth starting at its surface, the other from the solar system starting at the Earth's radius. Okay, so those are a couple examples. I'm going to stop there, and that's going to be it for escape velocity. There are black holes coming up next, so make sure you watch that video.